Hi friends, today I am giving a lecture on 0 by 1 knapsack problem using LIFO branch and bound. That means 0 by 1 knapsack problem can be solved using last in first out branch and bound. It is one of the important topic in branch and bound in design and analysis of algorithms. In this video, we have to solve one example problem on 0 by 1 knapsack problem using last in first out branch and bound. In the previous video, which procedure we have to follow to solve this problem that we are discussed in the previous video. Now, based on the discussion in the previous video, we are solving this example problem. Draw the state space tree for the following knapsack instance. N is equal to 5, M is equal to 12, P1 to P5 is equal to 10, 15, 6, 8, 4, W1 to W5 is equal to 4, 6, 4, 3, 4, 2. Find out optimal solution. Generally, knapsack problem is a maximization problem. That means we are getting the maximum profit by placing the maximum profitable objects by considering the capacity of the knapsack. But knapsack problem in branch and bound is a minimization problem. To convert this maximization problem into minimization problem, we have to put negative sign before each and every profit. Then the solution becomes the minimization problem. Then the problem becomes the minimization problem. After solving the given problem, then again put the positive sign in place of negative sign. Then the minimization problem becomes the maximization problem. First, we have to put negative sign before each and every profit. P1 to P5 is equal to minus 10, minus 15, minus 6, minus 8 and minus 4. Next, W1 to W5, there is no change in it. So that is 4, 6, 3, 4, 2. Here M is equal to 12 and N is equal to 5. Okay. Now the state space tree starts with a root node. So in that state space tree, there are three types of nodes are there. Live node, E node and dead nodes are there. For each and every node, we have to calculate lower bound and upper bound values. Here C cap is equal to lower bound and U cap is equal to upper bound. Okay, for each and every node in the state space tree, we have to calculate two bounds. One is a lower bound, it can be denoted by C cap, and another one is upper bound, it is denoted by U cap. While calculating lower bound for a particular node, it allows fractions of the objects. But while calculating upper bound, it does not allow fractions of the object. Okay. Next one is every state space tree starts with a root node. So that root node is 1. Every state space tree starts with a root node. That root node is 1. So now for this node, we have to calculate a lower bound C cap of 1 and upper bound U cap of 1. Okay. The first node upper bound, that is u cap is equal to u cap of 1 set as global upper bound. Set as global upper bound. Global upper bound. That is, first node u cap value can be set as global upper bound. Global upper bound is u cap. U cap is equal to u cap of 1 set as global upper bound. Okay. Now, the solution for this given problem can be denoted by solution vector x is equal to how many number of objects? There are 5 objects are there. x1, x2, x3, x4, x5. Here, each xi value can be taken as either 0 or 1. That means, suppose xi value is equal to 0 is nothing but ith object is not considered. Ith object is not considered. Okay, suppose xi is equal to 1, so that means ith object is considered. Ith object is considered means that object is placed into the knapsack. Okay. Okay. Now, first for root node we have to calculate the upper bound and lower bound. Okay. For node 1, first we have to calculate the lower bound, that is C cap value. Capacity of the knapsack is 12. Okay. First we have to place first object into the knapsack. Its weight is 4. It is less than the capacity of the knapsack. Then the corresponding profit we are getting after placing the first object, we are getting minus 10 profit. What is the remaining capacity? 12 minus 4, 8. Now, placing the second object into the knapsack. Second object is completely placed into the knapsack because its weight is 6, but the remaining capacity is 8. So that the corresponding profit we are getting minus 15. Next, what is the remaining capacity? 6 plus 4, 10. 12 minus 10, that is 2. But the third object weight is 3. But the remaining capacity is 2 only. So the entire third object is not placed into the knapsack. A fraction of the third object is placed into the knapsack. A fraction can be calculated. So remaining capacity by weight of the third object is multiplied with weight of third object. So now 3 cancel. Then 2/3 of the third object profit is minus 6. So 3 goes minus 2 times, then we are getting minus 6. So therefore C cap of 1 is equal to minus 10, minus 15, minus 4. That is equal to minus 29. Okay. Now go for U cap. While calculating U cap, fractions are not allowed. First, we are placing the first object into the knapsack. So what is the profit we are getting? Minus 10. Next, second object is placed into the knapsack. Then we are getting the profit minus 15. The third object is not placed into the knapsack because remaining capacity is 2, but the weight of the third object is 3. So fraction of the object is not allowed into the knapsack while calculating U cap. So that only 2 objects are placed into the knapsack. Then U cap of 1 is equal to minus 10 minus 15, that is equal to minus 25. Okay. So now first object is placed into the stack. First node is placed into the stack. Okay. Next, C cap of 1 we are getting minus 29 and U cap of 1 minus 25. So therefore U cap is equal to U cap of 1 is equal to minus 25. So this is the global upper bound. So global upper bound can be set as root node 1's upper bound value. Root node 1's upper bound value is minus 25. So then global upper bound U cap can be set as minus 25. Okay. Now node 1 can be extended or not. Okay. A node can be extended by its C cap value. So that means C cap of 1 is greater than the global upper bound. Global upper bound is minus 25. So that is equal to C cap of 1 is minus 29 is greater than global upper bound is minus 25. Minus 29 greater than minus 25. So this is false. So therefore node 1 can be extended. Whenever this condition is false, node 1 can be extended. Whenever this condition is true, node 1 is killed. But here the condition is false. Therefore node 1 can be extended. Node 1 can be extended. Okay. Next, global upper bound any is updated at node 1 or not. So that means U cap of 1 less than global upper bound U cap. That is equal to U cap of 1 is minus 25. Minus 25 less than minus 25. So this is false. So if this condition is false, then U cap is not updated. U cap is not updated. Otherwise, U cap is updated. Okay. So node 1 is extended and at node 1 global upper bound is not updated. Okay. Now we are extending the node 1 by taking x1 is equal to 1 and x1 is equal to 0. x1 is equal to 1 means we are considering the first object compulsory. x1 is equal to 0 means we are not considering the first object. Okay. 2, 3. So now node 1 can be popped out and placing its adjacent vertices, that is node 2 and node 3. Okay. Now among them, okay, we have to consider which node first. So in the stack, the last in first out principle is followed. Whichever element that is inserted last, that node can be popped out from the first. So that is which node we have to consider. Node 3 is considered. So for node 3, how we are reaching node 3 from root node? x1 is equal to 0. So x1 is equal to 0 means among the 5 objects, first object is not considered. Okay. So therefore the capacity of the knapsack is 12. Okay. First object is not considered. Go for second object. Second object is completely placed into the knapsack. Then the corresponding profit is minus 15. What is the remaining capacity? 6. Then place the third object. Third object is completely placed into the knapsack. Then the corresponding profit is minus 6. Next, what is the remaining capacity? 12 minus 9, that is 3. But the fourth object weight is 4, but the remaining capacity is 3. So complete fourth object is not placed. The fraction of the fourth object is placed into the knapsack. The fraction can be calculated. So remember remaining capacity is 3. Weight of the fourth object is 4 is multiplied with weight of the fourth object. Okay, 4 cancel. So 6 plus 3 plus 3, that is 12, equal to the capacity of the knapsack. 3 by 4th of the fourth object. Fourth object profit is minus 8. So therefore 4 goes minus 2 times, then we are getting minus 8. So therefore C cap of 3 is equal to minus 15 minus 6 minus 6, that is equal to minus 27. Okay, while calculating U cap, fractions are not allowed. So while placing the fourth object, so fractions are allowed. First object is not considered. Second and third objects are placed into the knapsack. So while placing the fourth object is not completely placed into the knapsack. Only fraction of the fourth object is placed into the knapsack. So that fractions are not allowed while calculating U cap. So therefore U cap of 3 is equal to minus 15 minus 6, that is minus 21. Okay, now node 3 can be extended or not. Okay, so that is C cap of 3 is greater than global upper bound. C cap of 3 is minus 27 greater than global upper bound is minus 25. So this is false, so that node 3 can be extended. Node 3 can be extended. So node 3 can be extended by taking 4 and 5. So this is 4 and this is 5. Okay. So 3 is, now what is the element that is there in the top of the stack? That is 3. Okay. Now 3 can be popped out and inserting its adjacent, that is 4 and that is 5. 4 and 5. Okay. Next, node 3, at node 3, global upper bound any is updated or not. So that is U cap of 3 is less than U cap. U cap of 3 means that is minus 21 less than minus 25. Global upper bound is minus 25. Minus 21 less than minus 25 is false. So that U cap is not updated. U cap is not updated. Okay. Now which node is considered? So here only top of the stack, which node is there? Node 5 is there on the top of the stack. Now consider node 5. So node 5, at node 5, here this is the second level. This is x2 is equal to 1 and this is x2 is equal to 0. Okay. Now go for node 5. So for node 5, how we are reaching node 5 from the root node? Here x1 is equal to 0, x2 is equal to 0, x1 is equal to 0, x2 is equal to 0. What is the meaning of that one? Okay, so first object is not considered and second object is not considered. Okay, first and second object is not considered. The capacity is used for placing the third, fourth and fifth objects. Okay, now the capacity of the knapsack is 12. Okay, now placing the third object. Third object weight is 3. It is completely placed into the knapsack because 3 less than 12. Corresponding profit is minus 6. Okay. Now, fourth object is completely placed into the knapsack because 4 less than 9. Okay. Remaining capacity 9. Here, fourth object weight is 4. So, 4 less than 9. It is completely placed into the knapsack. The corresponding profit is minus 8. Next, what is the remaining capacity? 12 minus 7, that is 5. Next, fifth object is completely placed into the knapsack. Its weight is 2 less than 5. So completely placed, and the corresponding profit is -4. But what is the remaining capacity? So 3. Remaining capacity is 3, but 5 objects are completed. So therefore, C cap of 5 is equal to -6, -8, -4. -6, -8, -4. That is -18. Okay. Here U cap is also same because so there are no fractions are there while calculating C cap. So that C cap and U cap both are same. If any fractions are there, it can be allowed in while calculating C cap. But here while calculating U cap, fractions are not allowed. Here there are no fractions, so that whatever the C cap value is there, it is equal to the E cap value. So that is U cap of 5 is equal to -6, -8. Sorry, this is -6, -8, -4. That is equal to -18. Okay. Now, node 5 can be extended or not. Okay. So, its C cap value is greater than global upper bound value. C cap of 5 is -18, greater than global upper bound is -25. -18 greater than -25. So, this is true. Okay. So, therefore, node 5 is killed. Node 5 is killed. So if the condition is true, we have to kill that node. If the condition is false, we have to extend that node. Okay. Then at node 5, global upper bound is updated or not. So that is U cap of 5 less than U cap. That is U cap of 5 is -18, -18 less than -25. Global upper bound value -25. So this is false. So that U cap is not updated. U cap is not updated. Okay. So node 5 is killed. Node 5 is killed. So then we have to popped out. Okay. Now on the top of the stack, which element is there? That is 4. Now we are considering node 4. How we are reaching node 4? X1 is equal to 0, X2 is equal to 1. X1 is equal to 0, X2 is equal to 1. Okay. That means first object is not considered. Second object is compulsory considered. If the capacity is available, use for third, fourth, fifth objects. So now calculating C cap. So capacity of the knapsack is 12. Okay. First object is not considered. Go for second object. Second object is compulsory considered. But after placing second object into the knapsack, the profit is -15. Remaining capacity is 6. Okay. Now placing third object into the knapsack. So its weight is 3. It is less than the capacity of the knapsack. Then the corresponding profit is -6. Okay. Now 6 plus 3, 9. What is the remaining capacity? That is 3. But the fourth object weight is 4. So it is not completely placed into the knapsack. Fraction of the object is placed into the knapsack. Remaining capacity is 3. But divided by weight of fourth object is multiplied with weight of fourth object. So 4, 4 cancel. Then 3 plus 3 plus 6. That is equals to 10. Then the corresponding profit is 3 by 4th of fourth object. Fourth object is -8. So 4 goes -2 times. Then we are getting -8. So therefore C cap of 4 is equal to -15, -6, -6. So that is equal to -27. Okay. Now, while calculating U cap, so fractions are not allowed. Fractions are there while placing fourth object into the knapsack. Up to second object and third object, there are no fractions. So, second object is completely placed into the knapsack. Third object is completely placed into the knapsack. While placing fourth object, we are getting the fractions, so that fractions are not allowed in the U cap. So, placing a fourth object is not considered. So that U cap of 4 is equal to minus 15 minus 6. So that is equal to minus 21. Okay. Now, so node 4 can be extended or not. So its C cap value. So C cap of 4 is greater than global upper bound. That is minus 27 greater than minus 25. Global upper bound value minus 25. So this is minus 27 is greater than minus 25 is false. So that node 4 can be extended. Node 4 can be extended. So node 4 can be extended. Okay. So but it's taking its children. Left child is 6 and the right child is 7. By taking x1 is completed, x2 is completed, x3 is equal to 1 and x3 is equal to 0. Now popped out 4 by inserting its adjacent 6 and 7. Okay. So at node 4, U cap value is updated or not. So U cap of 5 less than global upper bound U cap. That is, U cap of 5 is minus 21. Minus 21 less than global upper bound value minus 25. So this is also false. So therefore, U cap is not updated. U cap is not updated. Okay. Now, which node is considered